Hi, and welcome to another Hopper video. This is a Hopper on 6502 video or a Hopper 4th video, take your pick. It's, what a difference a day makes. When I first demonstrated this 4th implementation on the 6502, it was pretty slow. Because really I was just trying to test lists and records. But then I kind of got thinking and, like, how could I make this a whole lot faster? And obviously the one way to do it is to tokenize. So we had a record for each word, and we have a list of words. So the way I'm going to tokenize, this used to be string. So it used to be like the definition was just a list of strings like that. So now I'm making that a variant type. And this is a good illustration of how the variant type in Hopper works. Which means I can put a list of strings here, but I could also put a list of integers in here or everything else. And another problem we have is memory use. So I don't want to add more fields to this record because the word is, it's pretty fundamental to 4th. So the sneaky trickery we're going to talk about is I take the type of the variant as another field. So let's go see how I do that. So here's what I mean. So if we're looking at each of there's your list, the current definition is busy building and define word. Depending on the type of what the current definition is, it means something different. So a string is typically like a string literal, like you're trying to print out a string. Int is the stack type. So int is integer literals. So signed 16-bit integer literals. And that leaves me the byte and the uint type. So what I've done is I've made the byte represent built-in words. So it's the index of the built-in word rather than the string name of the built-in word. And the same for user-defined words, but I'm using uint for that. So that means I can have a maximum of 256 built-in words before I overflow into the area that I've reserved for user-defined words. And right now I only have about 50 built-in, so the first one of these starts at 51, say, but the type is uint rather than byte. So, well, in here, the type is uint. So this type gives us an extra field in the record, or an extra field in the string. So what I would have had to do was have two lists, like a list of variants and then a list of some identifier saying what that thing is. Is it a built-in word? Is it a user-defined word? Is it an integer literal or a string literal? Because you behave when you're executing. You behave differently based on what those are. So let's go have a look at what we're executing here. So when we're executing a word, based on the type of the word, we behave differently. So if it's a built-in word, we just go and execute its definition. So we go and fish, you've got a uint there. It pulls the uint out of the variant into index, goes and finds that word on the list of not built-in words, user-defined words, and gets that definition for the user-defined word, and then just recursively calls into execute the definition. If it's a byte, it's a built-in word, and it switches on the index. And I've got little comments in here showing what they were. So this is a bit fragile, but it's super fast now. And the Hopper implementation of switch cases is really efficient if they're integers. If you switch on strings, it's just like a chain of ifs. It's super inefficient. So most of the performance hit we took was from that. And then, so these are all the built-in words based on indices. And if we scroll down to the end of these, we'll see what's. I think we just what we do with ints, for example. So for ints, it's just a literal that gets pushed onto the stack. Yeah. And then a string could be two different things, because it might not be resolved to an index yet. If you sort of so yeah, anyway. But most of the time it's going to be literal. That's just going to be used. Okay. Enough of talk about how to get an extra field into your list. So my list, each element in the list actually has two values. It's got the value inside the variant and the type of the variant. And it works because I'm using the sneaky trick where the types mean one thing. So, an int type means integer literal, a byte type means built-in word, a uint type means user-defined word. So in my list here, I get two different values per entry in the list. Sneaky tricks. Okay, let's go have a look at it. So if I'm going to run from the Hopper monitor. Let's see. It's already uploaded onto, let's just restart it. So I didn't bother uploading it to the board because it's already there. So now if I control F5, it still takes a while to initialize the dictionary, because the real thing that's slow on the minimal runtime is string manipulation, because all the string manipulation methods are written in Hopper. So they're interpreted at runtime. They're being interpreted right now. But once you get to value types, once you have the integral value types, that's when the performance kicks in. So I think I'm pasting in a sample I used last time. So again, it's going to take a while. We're waiting now for it to tokenize this and basically define the word. So you can see it takes a little while. There, it's tokenized it. And now if I say countdown, and I had to talk my way through this last time as it was happening. It took seconds and seconds and seconds. Let's see how it does now. A hell of a lot faster. Yeah, much, much faster. Anyway, and I've updated the documentation online as well. So I've added, when I was doing the performance improvements, I was running benchmarks. So I've got some benchmarks in the documents as well, because there's no point in working on performance if you're not actually measuring how well you're doing. So here we are, we're defining this word again. It takes a little while to define the word because it's doing all that string manipulation to parse through all these words and tokenize them. Press enter, did I? There we go, tokenized. Now we run it. And now that blink is happening a little bit more like real time, it's supposed to blink, twice a second, every 250 milliseconds on and off, so 500 milliseconds a cycle, so it's blinking twice a second now. Whereas previously, the code execution was taking so long that the blink slowed down. Anyhow, sneaky tricks with the Hopper language. Sneaky trick to, if you've got a data structure with variants, and you can make the type of the variant be meaningful. So you can have, ints and uints and have them mean something different. Thank you for watching. If you're more curious about the Hopper language, I'll put the Hopper language playlist at the end of this video.